Question A. State the conditions necessary for 2 points on an image to be resolved by a CCD. Well, for that to happen, they need to be at least 2 pixels apart. At least. That's the 2 pixels is a minimum. Then we have the following data are for a CCD in a camera. The dimensions of the CCD are 24 millimeters times 16 millimeters, and the number of pixels is equal to that. So it says each pixel on a CCD is a square and they have the same dimensions. Show that the length of one side of a pixel is 6 micrometers. Well, we can firstly work out the area of a pixel. And to do that, we'll get the dimensions, the total area, I'll call it a small t, divided by the number of pixels, So that's going to be 24 times 10 to the negative 3, because it's millimeters, times 16 times 10 to the negative 3, and we're going to divide that by 10.2 times 10 to the 6. And that will give us our total area. So if we just do that on our calculator, we're going to have 24 exponent negative 3 times 16 exponent negative 3 divided by 10.2 exponent 6, and you get from that you get the area of 1. The area of a pixel is equal to 3.76 times 10 to the negative 11, and we know because they tell us it's a square, then the length of 1 will be that. So the area, obviously the area is equal to the length squared, so the length is going to equal the square root of the area. So I take the square root of that value of my answer, and you get here that your length is equal to about 6 times 10 to the negative 6. That's 6.1357. So it's about that meters, and here this negative 6 is your micro, so it's going to be 6 micrometers would be your value. In the next question there, it says the pixels have a quantum efficiency of 80% and a capacitance of 35 picofarads. Photons incident on a pixel at a rate of 1.6 times 10 to the 8 per second. Calculate the potential difference across the pixel after 12 milliseconds. Now, we know that our formula, I'm just going to work over here also just to give me some space. We know that our formula, that our capacitance is equal to our charge divided by V. So here we want to work out what our charge is. We actually know this value. So my V is equal to my Q divided by C. So we have this already. This over here is with this value over here, the C is 35 times 10 to the negative 12 farads. So we've got that, but we just need to work out our charge. Now we know that here that our charge, we have 1.6 times 10 to the 1.6 times 10 to the 8 photons per second. So it's 1.6 times 10 to the 8 per second. But we only are for 12 milliseconds. So I must multiply that by 12 times 10 to the negative 3 seconds. The milli is obviously times 10 to the negative 3. That will be the number of photons. But it's 80% efficient. So only 0.8 of them are actually going to be electrons, and the charge on each electron is 1.6 times 10 to the negative 19. So when I do that, I get a value of 2.5 times 10 to the negative 13, and my V is going to equal that divided by my 35 times 10 to the negative 12, and when I do that I get about 7 millivolts. Alright, and then for 3 it says a photograph is taken of a distant building using the camera. The magnification of the CCD is 2.2 times 10 to the negative 6. The two windows in the building are separated by 2.5 meters. Determine whether the image of the window can be resolved by the CCD. So we get our image over our object is equal to our magnification. So therefore our image is going to equal 2.5 times 10 to the negative 6. That's our magnification times our object distance, which is 2.5. And when we do that, we get 5.5 micrometers. So the image that's actually formed on your CCD is 5.5, which is not even 1 pixel, because remember we worked out a pixel was about 6 micrometers, so therefore it will not be resolved. And then for E it says, in terms of data storage, state 2 advantages of using a digital camera as compared to an analog camera that uses film. I'll answer that in a previous section, and you should know that, no problem. Thank you.